everyone. I am Dr. Jagadha Saravanan, Associate Professor, Head of the Department Mathematics, Institute of Aeronautical Engineering, Hyderabad. We are going to discuss the subject probability and statistics, in which correlation is the topic we are going to discuss in detail. First, what is correlation? The definition of correlation we are going to discuss. The next, the types of the correlation. The next one is problems based on correlation, called Pearson's coefficient of correlation. So these are the four topics, subtopics under the topic correlation we will discuss. The definition of correlation. It is the relation, correlation, the name itself, the relation is there. Relation between two variables. Usually generally, the relationship we know it, father and son, mother and daughter, or mother and son, the teacher and student, they are related, teacher and student relationship, mother and son relationship. So everything I am telling the relationship in the language I am communicating through this video, the language English. How to communicate these relationship in terms of mathematics, that we are going to discuss. We have to speak mathematically. So the mathematically, suppose the father and son is there. Their heights, how much height, how much weight they are. We want to discuss. Then father, I will assume one variable, x. And son, I will assume as one variable, y. So the two variables. So correlation, it's nothing but the relationship between variables. A small, actually to understand purpose, example, the live example I have given. Now you can see here that beautiful tomatoes are there. Here onions are there. So really, what is this? The topic is correlation. How this tomato and onions are correlated to this topic. Yeah, we will see it. The first one is correlation. It is a statistical analysis which measures and analyzes the degree or extent to which two variables fluctuate with reference to each other. That is, just now I have told father and son. Suppose the father we are taking as x variable and son has y variable. So between these two variables, how they are connected, that is our correlation. Now, the correlation expresses the relationship or interdependence of two sets of variables upon each other. One variable, we will call it as subject, that is independent. The next one, we will call it as dependent. So one is independent, another one is dependent. Now you can see it here. So the same picture, the three arrow marks are there. They are one direction. So because you can see here that the arrows, they are focusing on the completely the left side. Here we can see it. The three arrows, they are in the same direction. The direction is very, very important. Here we have taken price, that is some money, supply and demand. So here we can see it. Suppose in case that we know it our day-to-day life, sometimes the demand of the tomato, it will be more. The demand is more. Immediately the production the supply will be also increasing. So the demand is more. Automatically, we have to pay more money and we have to buy the tomatoes. The same thing for the onion also. So everything is increasing. Demand is increasing. Supply is increasing. And price also increasing. Everything more increase. They are in the one direction. In case the demand is very less, supply also very less, and price also very less. Here we are giving importance, direction. That is the most important thing. For that we have taken price, demand and supply, the three variables. These three variables, how they are connected, how they are correlated. If three are more, all the three are in the increasing and the same direction. If they decrease, all the three are going in opposite direction. But all the three are going in the same direction. This possibility, it is there. But only one doubt is ringing in our mind. Is it always? Even the demand is more, supply is more, price is more. Why can't? Sometimes the demand is less, price will be more. Opposite directions also possibility it is there. So we are going to discuss in detail these variables, what we assumed the price, demand and supply, or any relationship teacher and student, or father and son, mother and daughter, anything. These variables, whether how they are correlated, whether they are in the same direction or opposite direction, we are going to see. These pictures will make us to understand more about what is the definition which is defined for correlation. We can see now types of correlation. The correlation which is classified into many types, positive and negative, simple and multiple, partial and total, linear and non-linear. So these four mainly we will discuss. First we are taking price and demand. Both are in the same direction. Here we can see price and demand. They are also in the same direction. They are going towards left. They are going towards right. Otherwise, you can take it, these both are in an increasing stage. These both are in the decreasing stage. Positive correlation. This is one of the type of correlation. Positive correlation depends upon the direction of change of the variables. If two variables, that is our price and demand, price, let me take X, demand I will take Y. They move both. They are moving together. That is the point, is very important. Moving together in the same direction. That is, an increase in the value of one variable is accompanied by an increase in the value of other variable. That is, one is increase or one is more, another one also will be more or increase. If they are decrease, so if you are saying here, if demand is decrease, price also decrease. In the value of one variable which is accompanied by decrease in the value of the other variable. A simple word we can say, whatever the variables, they are moving in the same direction. If they are in the same direction, then it is positive correlation. We can see the example height and weight. We know it. If suppose 5 years old we are, our height will be some inches. And when we are growing more, our height also increasing. Our age is increasing. Along with that, our height also increasing. Sometime here rainfall, more rainfall, the production of crops, yield of crops are more. Rainfall is less, crops also less. So, but our variables fluctuating in the same direction. So that is what this is, positive correlation. Price and supply also another example. Here we can see it now, the demand which is in one direction, whereas price is in opposite direction of demand. But so the meaning is they are in the opposite direction. Then such a correlation, we will call it as negative correlation. So if two variables tend to move together in opposite directions, so that an increase or decrease in the value of one variable which is accompanied by a decrease or increase in the value of the other variable. Here you can see it, what I am underlining, increase or decrease. Here what I am decrease or increase. That means here increase, here decrease. Here decrease, here increase. Opposite. Such a correlation is called negative correlation. Or we can call it as inverse correlation. So here we can see it, price and demand. The second type, simple and multiple correlation. When we study only two variables, teacher and student, teacher is X, student is Y. So we are going to correlation between teacher and student, that is only the two variables. Here we have taken price and demand. So if you study only two variables, the relationship which is described as simple correlation. Example, price and demand. So the next one is, we added now one more variable, supply. If it is strictly only two variables, then it is simple correlation. But more than two variables if you study, then it is multiple correlation. So here we mentioned it very clearly. We study more than two variables simultaneously, then it is called multiple correlation. Price, demand and supply. So here we can see it. The next one is, we have taken price, demand and supply, partial and total correlation. Price, demand, supply. We are instructed, concentrate these three, price, demand and supply. Totally three variables. That means here we can take, this is X, here we can take it Y, this Z we have taken. Totally three, all the three we have to concentrate. But what we are doing? Among the three, the last one, supply, I am neglecting. So the three are given, one we are not concentrating. That is called partial correlation. We are neglecting among which what is given to us. If you concentrating all the total which is given, the total which is given to us is 3. Totally we are concentrating. That's what It is total correlation. You can see here what is written. All the variables are taken into account. It's called total correlation. That is price, demand and supply. The three are given to us to concentrate. All the three we are concentrating. That's what total correlation. Among the three, suppose in case we are neglecting demand, then it is becoming partial. The study of two variables excluding some other variables is called partial correlation. So here we neglected supply. So among the three, neglected one is supply. The leftover is price and demand. So the last one is linear and non-linear correlation. Here some data are listed here. 2, 4, 6, 8 and 10. If we focus on these numbers, yes, it is striking in our mind that what is the space between here? Here what is the space? Here what is the space? The space is 2. Here the space is, the difference is 3. So these data which are listed here, which are written here, they have the uniformity, the uniform space, the uniform difference values they have in between them. The first, the data, which has 2, the second one, 3. If they are the uniformity, if it is maintained, then it is linear. So we will discuss about that. If the ratio of change between two variables is uniform, then there will be linear correlation between them. Otherwise, it is called as non-linear correlation. So now we discussed about correlation and types of correlation. Based on this, the problems we will concentrate. Calculate the coefficient of correlation from the following data. Here we can notice it. Same now what we have discussed, the price, we named it as X. Same like that sum. It is, we named it as the variable X. The data which are given, totally 7 are there. 12, 9, 8, 10, 11, 13 and 7. Y, the data which is given, paired data, 14, 8, 6, 9, 11, 12, 3. For which we have to find coefficient of correlation. The great, the mathematician called Pierponts, he defined the formula for correlation to find the coefficient of it. Is using that we are going to solve this problem. So he defined a formula, that is summation xy, which is multiplied by capital N. What is the meaning of this capital N? The capital N is nothing but the number of paired data. Here we have 3, here, totally 7. So N we are going to replace it by 7. Summation X. The X data, sum we will find. We will do the addition. What we are going to get for this, the first row data, it's nothing but summation X. Because we named the variable as under which X variable the data are given, we are finding the addition, and that is summation X. Similarly, summation Y, X square So the x variable, squaring x into x, we will do it. This is different. Summation x, the whole square, we have to do it. Summation y square minus summation y the whole square. This is the formula which is given by Pierponts. So we can see it, the solution we will enter now. So the coefficient of correlation, the formula is, here we can see it, summation xy, same thing what we discussed, the formula only which is written here. Summation xy, which is multiplied by capital N, minus summation x into summation y, divided by square root of summation x square, which is multiplied by n, minus summation x the whole square into, that is everything, which is multiplied by summation y square into n minus summation y the whole square. So we will construct a table now. Why to construct a table now? What purpose the table to be constructed? Because we have seen, we have what is the formula which is defined by Pierponts. The formula, just now the previous slide, what we discussed it, to substitute in the formula the terms, the value of the terms are required now, for which we are going to construct the table. Yes, yeah, we are ready to construct the table now. Yes, the table we are constructing. Yes, the table is ready now. The table, the heading is computation of correlation of coefficient. What are the terms are there in the formula that we are going to find out the values. The first one, x, which is given in the question, x under which the data are there. So under which, what are the data are there? That which are listed here. We found summation x completely, this full complete data we added. We got summation x equal to 70. So the next one is y. This is also which is given in the question. So now here completely we are going to add. We are getting summation y equal to 63. The next one is x square. So here we can see it. 12 square, 144. 9 square, 81. 8 square, 64. 10 square, 100. 11 square, 121. 13 square, 169. 7 square, 49. And we added this complete summation x square is nothing but 728. The next column is y square. We can check it. 14 square, 196. 8 square, 64. 6 square, 36. 9 square, 81. 11 square, 121. The similar way, 12 square, 144. And 3 square is 9. The completely we will add, we got it, summation y square equal to 651. xy. Here our x is there, here y is there. Both we have to multiply. So the multiplying 12 into 14, we got it 168. 9 8s are 72. 8 6 are 48. 10 9s are 90. 11 11s are 121. 13 12s are 156. 7 3s are 721, the total summation xy, which is equal to 676. So summation x, summation y, summation x square, summation y square, summation xy. All these are terminating in our Pearson's coefficient of correlation formula. So we constructed, it is required, it is needed, it is must, these to be found to substitute in the formula. So we can see it. Just once again we are writing what are the values we got it before substituting in the formula. That is summation x equal to 70, summation y equal to 63, summation x square equal to 728, summation y square equal to 651, summation xy equal to 676. So now coefficient of correlation formula is, so this is the formula, that is summation xy into n minus summation x into summation y divided by square root of summation x square into n minus summation x the whole square. So what we have done towards the variable x, this seemed similar, the step or treatment we have given to the other variable y. Same, the similar way, the treatment which is given. Now, our summation xy is there. We can pick up, this is the value to be substituted in this particular place. Summation x, here the value which is there. Summation y, here the value which is there. Summation x square. We have to be very careful. Summation x square, summation x the whole square, both are different. There is a room. We can commit here the careless mistake. So this particular part we have to be, while substituting the values also, we have to be little, the care attention to be taken. Here summation x square, here 728 into n. The capital N is the number of paired data. So summation x the whole square, here 70 square. Summation y square is 651 into n minus summation y the whole square. So here 63 the whole square. We can see it. Now we substituted all the values what we have discussed now. So it's a similar way it is written. So we can see it here. It is nothing but here this is summation x the whole square. Our summation x is 70. So 70 square, 4900. Summation y the whole square, that is 63 the whole square. It's nothing but 3969. So the numerator part, the simplification which is done here, the 676 into 7, 4732 minus 70 into 63, 4410. Coming to the domain of the denominator, 728 into 7, it is 5096 minus 4900. 651 into 7, that is 4557 minus 3969. Here we can see it. So the numerator is 322 divided by square root of, this value is nothing but 196. This value it's nothing but 588. So the numerator is 322 divided by the denominator value square root of 196 into 588, it's nothing but 339.48. Approximately the coefficient of correlation, the value we obtained 0.948. So we can write it 0.95. So this is the final result which we obtained for this given problem. So we can see it the next problem. Find Pearson's coefficient of correlation from the following data. So here we can see it the problem, the data which are given, wages. So the wages, the name which is given, we can assume that wages as X variable or some name variable we have to define. The data which are given, 100, 101, 102, 102 is repeated 2 times, 100, 99, 97, 98, 96, 95. Totally 2, 4, 6, 8, 10. 10 data are given. The second one is cost of living. So paired data. 10 paired data are given. The previous problem, what we discussed, the data are very small. That is easily we can find the squares and all. But here these data is little bit, there is more values are there. How to deal this type of problem? We can see it here. The small r which represents correlation, coefficient of correlation. The formula is, the previous one is one of the formula, this is another one. Summation xy divided by square root of summation x square into summation y square. So we will enter this formula only. With the help, we are going to solve this given problem. So the Pearson's, the coefficient of correlation formula is summation xy divided by square root of summation x square into summation y square. So we have to construct the table to substitute the terms, values. Based on that, the table we will construct now. So we are constructing. So we can see it that the columns, the lines, the vertical lines which are drawn here, wages which is given, that we are assuming as some variable. That is only our topic. We have to define the relationship between the variables. Ours is wages. We given the name, wages are named as X. The data which are given under which they are listed here, 100, or the 10 data are written here. We are finding summation X. It is 990. Here, the capital X we are finding. Why suddenly we have to introduce capital X? Because the previous problem, what we discussed, this capital X part and all not at all there. Then why this specifically in this problem we have to do this method? Because the data are, we are noticing, the values are more. The time taking processing. So in such situations, we can go for mean, average finding. Then easily we can solve. For which first we have to find X bar we have to find. The X bar to find, here summation X is there. Divided by sum of the observations. What we studied in lower classes, earlier classes. Sum of the observations divided by number of observations. So we can see it here. So that to be found Just we will come back. Here we can see it, this slide which is kept here. So just I gave the thing. X bar first we are finding. Summation x by n we are doing. Summation x, we calculated it. 990 we got it. So the 990 divided by 10, 99. Similar way, y bar also we have to find. Summation y by n, 950 by 10 which is equal to 95. So we will go back actually. So here we can see it here. So the x bar. X is 100. X bar is 99. That I have just now shown the slide. That is 990 divided by 10. We got it 99. So here x is taking 100. 100 minus 99. We got it 1. The second one is 101 minus 99. We got it 2. Third one, 102 minus 99, 3. Similar way, now this is also 102 minus 99, 3. 100 minus 99, 1. 99 minus 99, 0. 97 minus 99, minus 2. 98 minus 99, minus 1. 96 minus 99. It is minus 3. 95 minus 99, minus 4. If the values are more, this is the very easiest method to adopt it. So now, mean we have find it. With the help of that mean, x minus x bar we have done it. So we got these values. Now, capital. Yes, summation capital X equal to 0. To make the difference between the variables, here there is maybe the confusion. Very easy way, mean if you are adopting, what is the given, the question, whatever it is given, wages or the teacher or anything, we will take small x. Capital X is x minus x bar to be defined. Then we won't get any confusion at all. Easily we can solve, all the students we can come out. Capital X square. Because in the formula this term it is there. Our aim is the values to be substituted in the formula. Based on that we are constructing this table. The table name is computation of correlation of coefficient. Now, 1 square, 2 square, 3 square, 9, 3 square 9, 1 square, 0, minus 2 the whole square, minus 1 square, minus 3 square, minus 4 square. We know it. The negative square is always positive. So we got it now, capital X square. So summation capital X square equal to 54. Wages, that is our given question, that we assumed a small x, we defined capital X in such a way that x minus x bar, we found capital X square, the complete the treatment to the variable x we completed. Let us move to cost of living. This is another one which is given in our question that we are assuming as y. So what is the data which is given under which cost of living which is written here. So now, so for these 3 columns, what we have done it. The same we are going to do cost of living that we assumed as the variable y. Now summation y equal to 950. So the now here capital Y is nothing but y minus y bar. Again, the y bar is mean. Mean. So 950 divided by 10, it's nothing but 95. So 95 is our y bar. So 95 minus 98 is 3. 99 minus 95, 4. Everything calculating we listed, we have written here. So 99 minus 95, 4. 97 minus 95, 2. 95 minus 95, 0. 92 minus 95 is minus 3. Here 95 minus 95 equal to 0. 94 minus 95 minus 1. Similar way. Other two also we got it. Simple way. 90 minus 95 minus 5 and 91 minus 95 minus 4. So summation y we added. We got the value 0. So now capital Y square we are finding. Where is 3 square, 4 square, again 4 square, 2 square, 0 square, minus 3 the whole square, 0 square, minus 1 square, minus 5 square, minus 4 square. We found summation y square. The value is 96. xy. Here we have to be very careful. Capital XY. We should not get a confusion here, small x and y. Capital XY. This and this. These two to be multiplied. So here we can see it. 1, here 3. Here we can see it. 3 which is written. And just I am putting a small tick. They are multiplied. Here 3, 4, 12. The next one 3. Here, yes, I'm sorry. I put it wrong here, tick. Here 3 2s are 6. Next one, 1. Here. No, I am putting the tick here, sorry to say. Here we can see it, x, and here the thing it is there, y, 0. The similar way it should be written. The last one we can see it, x, and here y, minus 4 into 4, 16. Here minus 3, minus 5, it is 50. So this is the way we have to multiply. Here the space is not convenient. Here which is written, summation xy, the value is 61. All the terms, values we found, we are going to substitute. The leftover part, substitution in the formula. So we can see it. This is actually before in hand I explained it. So what are the values we got it to substitute in the formula? Once actually we are written here. Summation xy equal to 61, summation x square equal to 54, summation y square equal to 96. So the Pierponts coefficient of correlation formula is r equal to summation xy divided by square root of summation x square into summation y square. What are the values we obtained? 61 divided by square root of 54 into 96. So 61 divided by 72, it's nothing but 0.847. So one more problem we can say to find the coefficient of correlation between x and y from the following data. We can see here 6 data are given under the variable x. The next one, the paired data for the variable y. Solution, the coefficient of correlation formula, the first formula we have taken here, the data or the values are very small. Any formula we can use it, nothing wrong in it. So summation xy into n minus summation x into summation y. This is the part which is dominating in our Pierponts coefficient of correlation formula. numerator. What about the denominator? The square root of summation x square, which is multiplied by n, minus summation x the whole square. Completely what we have written for the variable x, the same should be written for the variable y. This is all small sort of technique to remember the mathematics formulas. So we will construct the table. So the correlation, the coefficient of correlation to find, compulsory we have to construct the table based on the terms values to be substituted in the particular formula. So we are constructing x, under which what are the data which are given, we substituted it. Summation x, it's nothing but 114. Now y, the value which is given 13, 18, 12, 25, 30 and 10. So we are adding the complete the data we added. We got 108. X square we have taken. So here we can check it. 10 square, 12 square, 18 square, 24 square, 23 square, 27 square. Now the leftover, we know it very well, summation x square to be found. So we obtained the value 2402. The next one is y square. 13 square, 18 square, 12 square, 25 square, 30 square, 900, 10 square, 100. Now, summation y square, we added the complete y square value, we obtained 2262 xy. So these two to be multiplied, 10 into 13, 130, 12 into 18, 216, 8 into 12, the same 216, 24 into 25, 600, 23 into 30, 690, 27 into 10, 270. Now, completely we added this column, that is multiplication of the two variables, fluctuating the variables between x, y, that is the term value of xy. We added the summation of xy is 2122. So the complete the table we constructed, computation of correlation of coefficient. All the terms are ready now. The substitution part is, before that what we obtained the result, once we can see it. Summation x, it's nothing but 114. Summation y is nothing but 108. Summation x square equal to 2402. Next, summation y square equal to 2262. Here, summation xy is 2122. All the values are ready. Now, we will enter into the formula, that is our coefficient of correlation formula is summation xy, which is multiplied by n. N is nothing but our number of paired datas minus summation x into summation y. This is the numerator part which is dominating, divided by, here's the square root of summation x square into n minus summation x the whole square, the totally everything which is multiplied by summation y square into n minus summation y the whole square. Now the substitution part we will concentrate now. So now we are focusing on the substitution part, that is summation xy. Here we can see it very clearly, which is kept in the side, 2122. In the question, the number of paired data which are given, 6. The minus which is in the formula already it is there, just we have written. Summation x is nothing but 114. Summation y, it's nothing but 108. Coming to the numerator, the numerator part we completed. Coming to the point of denominator, summation x square. Here the value is there, 2402 into 6 minus summation x the whole square, that is 114 the whole square. Summation y square, here it is there, 2262 into 6 minus summation y, it's nothing but 108 the whole square, because here already the square is there. So the completely the part of the numerator we obtained after the operations of multiplication. So 12,732 minus 12,312. Coming to the denominator, square root of two terms are there. The first one, the simplification, 14,412 minus 12,996. This is one part. The second part is 13,572 minus 11,664. So the simplification of the numerator is 420 divided by, coming to the picture of the figure of the denominator is square root of 1416 into 1908, which is equal to 322 divided by 1644. So finally we obtained the result 0.255 approximately. So we will come to the conclusion of this topic, correlation, the subject probability and statistics. We discussed correlation, the relation which is correlated between the variables. So types of correlations, positive correlation, the variables which are move in the same direction, or either any direction, let them go, but all they will be in the complete the variables what we are going to define, they will move in the same direction, then positive. If they are in opposite, negative. We will talk about only two variables, simple, more variables, multiple. And what is the variables they are giving to us? Suppose they are telling the relationship between 5 variables. All the 5 we consider total correlation. If you neglect any variable, partial correlation. And the space between the given data is uniform, linear correlation. If they are not uniform, non-linear. Everything we discussed in this video in detail. And coefficient of correlation formula, that is this formula using we discussed, we solved, we constructed the table to substitute in this formula what are the terms are required. Based on that, construction is done. Then the capital N is number of paired data. And one more formula also we discussed, that is R equal to summation xy divided by square root of summation x square into summation y square. So everything in detail we discussed through this video. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.